Hey guys, today we're going to talk about verifying trigonometric identities. First, we're going to go over some identities that we're going to use in this lesson. The reciprocal identities, sine x is the reciprocal of cosecant x, so that's 1 over cosecant x. And cosecant x is 1 over sine x. Cosine x is 1 over secant x. And secant x equals 1 over cosine x. And tangent and cotangent are reciprocals of each other, so tangent x equals 1 over cotangent x, and cotangent x equals 1 over tangent x. The quotient identities, tangent x is equal to sine x over cosine x, and cotangent x is equal to cosine x over sine x. The opposite angle identities, we're actually not going to need to use those in this lesson, so we'll go on to the Pythagorean identities. Sine squared x plus cosine squared x equals 1. And if I was to subtract cosine squared x to the other side, it would be sine squared x equals 1 minus cosine squared x. Or if I subtract sine squared x, I would get cosine squared x equals 1 minus sine squared x. Tangent squared x plus 1 is equal to secant squared x, which means tangent squared x equals secant squared x minus 1, and 1 equals secant squared x minus tangent squared x. And 1 plus cotangent squared x equals cosecant squared x, which means that 1 equals cosecant squared x minus cotangent squared x, and cotangent squared x equals equals cosecant squared x minus 1. So when we verify a trigonometric identity, that means that I need to make this left side equal the right side. So that I'm actually already saying they are equal, but I need to make them look identical. And what that's actually doing is proving that this statement here is true. So some strategies that we can use that are going to make this a little easier is, first, if we put things in terms of sine and cosine, that's going to make it easier to work with. If we see a trig function squared, there's a possibility that it's one of these Pythagorean identities right above here. If we're going to have to add or subtract fractions, we need a common denominator. Multiplying or dividing, we don't. If we have one complicated side and one that looks rather simple, we'll just take that complicated one and try to make it look like the simpler side. And we need to work both sides algebraically. We need to use rules of algebra, like what we do to one side, we have to do to the other. So example 1, sine, that's already in terms of sine or cosine, so I'm going to keep that just as it is, sine x, times cotangent x. According to our quotient identities, cotangent x is cosine x over sine x. The right side's already in terms of cosine, so I'm good with that. Now when I multiply this, I'm going to get sine x times cosine x over sine x, and those sine x's are going to cancel. So I get cosine x equals cosine x. The two sides equal each other, so I have proven that this is true. So I'm not going to put a box around this because this isn't really an answer to a problem. All of these are my steps to show that this is a true statement here at the top. So it's a proof, not a problem requiring some particular answer. Example 2, cosine squared x, that's already in terms of sine or cosine, so I'm going to keep that as it is, times cosecant x, and cosecant is the reciprocal of sine, so that's 1 over sine x, times secant x, which is 1 over cosine x, equals cotangent x, and cotangent is cosine x over sine x. So on the left side, if I multiply my numerators and my denominators, I'm actually going to be able to cancel out a cosine from the numerator and the denominator. So I've got cosine x times 1 times 1, cosine x. Sine x times what's now a 1 is sine x. And the right side is cosine x over sine x. The two sides match, so that proves that this is a true statement. In example 3, secant, I'm going to change that to terms of sine or cosine. Secant is 1 over cosine x minus cosine x equals sine x times the tangent is sine x over cosine x. So I've got some fractions here that I need to subtract, and in order to do that, I need a common denominator. So to get my common denominator, I'm going to have to multiply the numerator by cosine x and the denominator by cosine x. So what I get is 1 over cosine x minus cosine squared x over cosine x. And I can combine those into one fraction, 1 minus cosine squared x over cosine x. On the right side, sine squared, or sine x times sine x is sine squared x. From the Pythagorean identities on the front page, we can see that 1 minus cosine squared x is equal to sine squared x. Now my left and right side are identical, so that proves that this is a true statement at the top. And number 4, cosine x is in the terms I want. Secant is 1 over cosine, so that's 1 over cosine x. Cosine x is good. Cosecant is 1 over sine. Since this side is far more complicated than the right side, I'm just going to leave the right side alone for now and simplify the left side, and we'll figure out later on what we need to do with the right. I'm going to multiply these fractions here. So this is cosine x over 1, so I'm going to multiply those. Cosine x times 1 over cosine x plus cosine x over sine, and this should actually be sine squared x. Cosecant squared is sine squared, so sine squared x. So next I'll distribute this cosine x. So I get cosine x over cosine x, which is 1. And cosine x times cosine x is cosine squared x. Cosine squared x over sine squared x. Cosine over sine is cotangent, so cosine squared over sine squared. So 1 plus cosine squared x over sine squared x is cotangent squared x. And from our Pythagorean identities, we can find that 1 plus cotangent squared x is equal to cosecant squared x. And that actually is exactly what we had on this side. So I don't have to change that at all. And we'll stop with those 4 examples for today, and we'll come back and finish up the rest of these in our next video.